This is a recording of a live webinar held on September 6th, 2023, the last in our four-part series entitled Expert Insights, Industrial Efficiency. Check out the previous 3 parts on metalworking fluids, cleaners, and pretreatment on our channel, where you can also find product demonstrations, instructional guides, and more. Click the link in the description to learn more about DuBois webinars or to follow us on LinkedIn to be in the loop of upcoming events.
Good afternoon, everybody. I got 1 o'clock on my time, so we are going to get this started. Thanks again for joining this webinar. This is our final of 4 webinars in a series focusing on manufacturing, just kind of sustainability is the backdrop along here. We began to do these webinar series because 2 reasons, really. We have FabTech coming up next week in Chicago. DuBois is exhibiting there. Please feel free to visit us. Our booth number is D40130, and we have a couple talks that we're giving in the conference, See It, Touch It, Fix It, and Maximize Your Paint Finishing System. And, with growing regulations and growing concerns about the environment and the world, sustainability's kind of been a huge topic that's been popping up and something that everyone's been real concerned about. And a lot of times with sustainability comes savings and costs, or there can be in that respect. So what we had here today is we brought on Rich Moore. Rich Moore, he's worked at DuBois Chemicals for about 27 years. That's a long time. 13 years in R&D for surface finishing, and then 14 years being the technical manager, and now the senior product line manager for water treatment. Basically, his backgrounds in both pre-treatment and wastewater treatment allows him to give complete solutions to a wide variety of people, anywhere from people just looking for water treatment and people looking for wastewater in an industrial environment. He's talking today about how to minimize waste costs with effective water solutions. If you'd like, we're going to try to answer all the questions here at the end. We're going to be monitoring, so please feel free to keep up. And with that, I am going to turn it over to Rich. Rich.
Hey, thanks, Max. Hopefully you can all hear me all right. Want to thank everyone for attending here today. And I can't think of really a better time, going back any time in my career here, to be given a talk on sustainability and water treatment. Really, Max touched on this a little bit, but if you turn on our news, we're inundated with lots of things on a changing environment out there. And I'm not doing this to be political or anything like that. So whether you feel like all the things going on in our environment and the weather, and we got another hurricane, I think, brewing out in the Atlantic that is supposed to get up to a Category 5. We have floods in Nevada and in Las Vegas, where you just see basically rivers of water going down the streets of Vegas. And we've all seen the wildfires, not just in Hawaii, but up in Canada, that has made a lot of the United States down here have their skies turn pink and red at different points of the year. All these things are going on. And like I said, it's not really a political thing. It's kind of a reality now. And whether you think it's due to man-made changes, whether you think it's due to just the cycle of the Earth, and it's just the time and meteorological changes just occur over time, it doesn't matter. We got to deal with what's going on. And when you see these type of issues come up, it puts the stress on our resources. So when we're talking about sustainability, and especially in water treatment, our most precious resource we always hear is water. And we're here. We have systems and methods to help preserve that commodity and that resource. And we're going to talk a little bit about that today. And Max also touched about this, but another thing I'm excited about with this is, 10 years ago, 15 years ago, the term sustainability wasn't really out there yet, and everyone just talked about going green. And one of the things I always said back then is it's nice to be green to conserve the environment, but really also green's the color of money. And whenever we have these opportunities for water savings and for resource savings, we're also affecting our companies, and our production costs go down. And then we're saving on the bottom line. And I think as you look at it today, I think there's, whenever you turn on the news, there's something, have we been in a recession? Are we in a recession? Are we going to be in a recession? We all know the way inflation has hit us. And even though it's calmed down a little, it's still going up. And prices, instead of being 12 or 15% like 2 years ago, prices are up 8%, but that's over those already high prices. And it's affecting us in our daily lives every way. And I think we've all been hit with it in our work lives as well. But when we go at a water treatment process and we save water, and when we do that, we're going to get into how that also saves energy. We can cut costs out of the process. So if we're in an economic downturn, let's say in the next year, and the economy is going to go down, so you're not going to be able to sell as much as you have. Cutting costs becomes really important. Number one, cutting costs. Maybe that can allow you to grab market share. Maybe you sold, let's say you sell televisions and you sold 100,000 of them last year. Do the economy, you're going to sell 90,000. Your boss, your shareholders, investors are not going to like that. But if you cut cost, maybe that lower cost you can pass on to the customers, and you can still sell 10,000 televisions. Just use an example, and then everyone's going to be happy that you're able to maintain sales and grab market share. If profits are going to be down because you're selling less, saving cost can help drive profitability. So maybe sales are down, but profits are up. So again, another important time to be looking at saving. And we all know the effects on inflation, how we've seen that. So we're looking to cut costs wherever we can. And you can do that through water treatment. So I think it's a perfect time to talk about this, not only because of what's going on in our environment, but also what's going on in the economy and in our business cycle. So we move ahead. First of all, I want to talk a little bit about what DuBois water treatment is in the areas we serve and what we offer. So we consider ourselves, we're a North American leader in mid-market applications. The water treatment side of the business, we supply chemistry for treating water using cooling towers, boilers, closed loops, cleanup products, dispersants, and we're also a leader in providing solutions for water safety and Legionella risk management. We've had reps that were on the front lines in New York, in Quebec, in Vancouver, in these areas where laws have popped up governing the need to have Legionella risk management plans. So we've really become an industry leader at providing management plans and controls, and also implementing those plans in the field and having chemical and equipment solutions to prevent Legionella. The other part of our water treatment business is the wastewater side. So we have a full line of wastewater products, coagulants, flocculants, metal precipitation, sludge dewatering, emulsifiers, pH adjustment, and odor control. Going a little bit, and this gets into a little bit about DuBois and our water treatment growth. So back in 2009 is when DuBois had spent many years being owned by other chemical companies. In 2009, we kind of spun off into private equity, and from then we've been on a growth cycle. So one of the goals when DuBois first went out on its own was to develop certain sectors to be leaders throughout North America. One of those is water treatment. So beginning in really before 2011, DuBois was strong in water treatment, but only in certain geographies: the Midwest, Great Lakes area, the Northeast United States, and we had a small presence of guys that did a good job with water treatment out in Southern California. But beginning in 2011, we started to expand that footprint. We wanted to be able to offer water treatment across the entire United States, and we first acquired a company called Midco. Midco was headquartered in Grand Rapids, Michigan, had strong presence in Michigan, Ohio, Indiana, Wisconsin, the Great Lakes area, but also had a presence going down through the plains and down into Texas and Oklahoma, Kansas, Missouri, and Texas. So that started to expand our footprint into different areas. Then about 5 years ago with BHS Chemicals, BHS is primarily a food chemical industry and involved in that, but they had acquired in previous years 2 water treatment companies that became part of DuBois. So WestChem operated in the western states, California, Nevada, Arizona, Colorado, out in that area, and Steam Engineering was active in the Pacific Northwest, Oregon, Washington, Idaho. And you can see how, just with those 2 acquisitions, we expanded throughout a lot of the United States. We still had, some weak areas, especially in the Southeast, but then that leads us up to 2018 when we acquired Tri-Water Holdings. Tri-Water was a group of companies that all did water treatment. First, Cleanzoid up in Canada was a leading provider of water treatment in Canada. So now we could expand our footprint into Canada. An arm of Cleanzoid sold in the United States under the name of Eldon, and they were strong in Michigan and Ohio, further emphasizing our base there. Nashville Chemicals would have allowed us to expand into the Southeast. So we became an industry leader in biocide supply with the acquisition of Nashville, both to water treatment applications and oil and gas applications. But at the same time, Nashville had a direct sales force in the Southeast. So now we already talked about DuBois being strong in the Northeast and in the West and the Midwest. And now with all these acquisitions, we brought in, a farther presence out West, presence in the Southeast, stronger in the Midwest, and down into the Gulf states as well with some of these acquisitions. Chemco is a company in the Midwest, primarily ran in Michigan, but was very, very strong with potable water and defoamer applications. So we brought that into the line. You see Bugman and Eclipse there. That's a product line. Bugman had a direct water sales force. Clenzoid had bought that prior to DuBois buying Clenzoid. So where you see Eclipse products used in Canada, which are used coast to coast in Canada, those are offered now through DuBois and are manufactured by DuBois. Around the same time, we bought IPAC, which had a water treatment division that operated out west in Vancouver. So now we're able to cover coast to coast in Canada with the Clenzoid and IPAC acquisitions. And I already discussed how we're coast to coast in the United States. Finally, last year we bought Chemfax, which makes us an industry leader in Canada and glycols. They got some unique chemistries we're eventually going to bring to the United States here later this year. But Chemfax, strong throughout Canada, but especially in Western Canada. They're headquartered in Calgary. And they actually have manufactured in Calgary. So along with these acquisitions, we have water treatment focused manufacturing plants now in Nashville, Tennessee. We did make water treatment products in Nampa, Idaho as part of the BHS acquisition. We have the DuBois Legacy plant in Sharonville, Ohio, and also now a plant in Calgary. So we have manufacturing and laboratory expertise in those locations. So we truly are a North America leader and have a geographic footprint that we have water treatment experts throughout all of North America. Okay, so as we brought these companies together, each company would have its own culture, way of doing business, way of doing sales, how they operated on the field. So starting back in about 2019, we brought everyone together from these different companies and kind of figured out, okay, what's DuBois Water Treatment going to be? What are going to be our priorities? And this statement here comes right from basically the mission statement that we wrote. So several paragraphs long, but this is just one sentence I think really sums up how we do business and really ties into our topic today. And that's we'll continue to be stewards of natural resources, reducing water and energy consumption, and promoting chemistries with minimal environmental impact. So, being someone that's been in the chemical industry, usually that gets a black eye when it comes to environmental aspects. We want to reverse that trend and become stewards of our resources and not negative, not become polluters. So we've really focused on sustainability through water treatment, and we feel it's our best way as a company to deliver what our customers want and what our customers need. So moving ahead here, so this gets into a little bit of our resources and why it's important to save our resources. And this goes into that environment I was talking about earlier. So we always hear water is the big blue planet, and you because of that, you tend to think that we have unlimited amount of water that we can use. But if you take all the water on Earth and put it into a sphere, it would be only 860 miles in diameter. But a lot of that water is salt water, and we can't use it. We can't use it for your manufacturing process. We can't use it to drink. We can't use it to cook. In a lot of cases, you can't use it to clean, because if you clean anything with metal, it's going to corrode it. So that water is unusable. So to have good, available, fresh water, that reduces that sphere even more. But a lot of that water is tied up in our poles in terms of being in ice and glaciers. And yeah, it'd be nice to take a chunk of ice and melt it and have water for everybody, take it to the desert and make an oasis, but that's just not practical. So at the end of the day, when you take out all the salt water, all the water tied up in ice and glaciers, the available water for a whole world to use, and this is for all time. If anything, it's getting smaller when we pollute it and make it unusable, but the amount of water we have stays steady. The water evaporates, it comes back down at Earth, and it follows that cycle over and over again, is 170 miles wide. So think of that. I'm in Northeast Ohio right now, a suburb of Cincinnati, Sharonville, not Northeast Ohio, Northeast Cincinnati, 170 miles wide. This sphere could fit between here and Cleveland, Ohio. So basically a footprint of the state of Ohio is all the water for all the world to use from here to eternity. And our population's always only getting bigger. So that's why water's scarce. It's not just environmental concerns in terms of droughts in certain areas, and that does complicate things. But it's also just we have a growing population and a steady amount of water we can all use. So we got to find different ways to share that water because we need it. We need it for manufacturing. We need it for our health. We need it for cleaning. We need it to drink. Um, and it is limited as more and more people come into the world. And I think you've all seen water bills are higher than they were 5 years ago. They're higher than they were 10 years ago, and they're only going to continue to get higher. So even where water is accessible, it's become a more of a cost where maybe 25, 30 years ago, it wasn't much of a cost you took into account in your manufacturing process. Nowadays, it needs to be because it's more and more expensive. So when we talk about water and water scarcity, then, and I think a lot of people have heard this buzz term of water scarcity, it's not just availability of water. It needs to be water that's in the right quantity, in the right place, the right time, and right quality. Like I said, the rain that they've gotten in the desert in Nevada is causing flooding there. Every spring, if you live by a river along the Mississippi or the Ohio or wherever you are, you get rain and you end up getting flooding. In those cases, you have a surplus of water, but it's not the right quality, so you can't use it. It's dirty, it's muddy, it's unhealthy. It can't be used of anything. If anything, it's a nuisance. So that water doesn't do any good. And even now, like let's say in Nevada, you got a lot of water there now, but then when we go another year without rain, it's not the right time a year from now. So you need water in the right place at the right time in the right quantity. It just can't be available. It has to be the right supply of water. And when we look at our water treatment business, we're trying to solve this water scarcity issue every day. That's what we're doing when we design our program. So when we design a water treatment program, we're designing a program to overcome these issues. Number one, if water is scarce, to use less of it. That's number one. What we always try to do is increase water savings, use as less water as possible to get the job done. But especially if it's scarce, it becomes, a fact of doing business to use as less water as possible. Number two is to manage seasonal changes to water. Oftentimes you might be able to save money on water by drawing from a well during certain parts of the year and not from a river or municipal source. But if that well dries up, you end up with different water qualities, which can really affect the water system. We can manage that, and we can use our expertise and equipment and our chemistry to manage that and not have it be where you're going to corrode your system or scale your system when you undergo those changes. And finally, we can change the quality of water to make it usable. A good way to think of this is, water has impurities in it: calcium, carbonate, magnesium. And a lot of times we've all seen where water dries down and leaves salt. Well, if you're manufacturing something and your water is too high in those solids and it dries down on a part, it could cause quality issues. It could be, number one, just a bad appearance issue. Let's say you're cooling a bottle of wine and you cool it with water and you leave a bunch of salt behind. No one's going to buy that off the shelf with a bunch of salt on it. So you get those kind of issues. But also, if you're treating metal or something like that, and the end part has a bunch of salt on it, that could lead to corrosion down the road or other defects. So you need the right quality of water to promote manufacturing excellence and to get the end part what you want it to be. And then we can do things to change that quality, to help make the water better and more suitable to be the right quality to use in your system. If it isn't available from your city or from the well or wherever you are, if the water is not of high enough quality, we can design programs to help there. Okay, so sustainability through water treatment, how we do this is number one, we use the best practice approach. We're a chemical company, but why we wrote that mission statement is we don't want to just be chemical salespeople. We're really selling best practices that promote water savings. And think about it, as a water treatment company, if we're treating 2 million gallons of water and we save you half of that, and you only now are using 1 million gallons of water, we're probably going to use half the chemistry because they're treating less. But we feel that doing that not only helps our world out, but it helps us out, because if we're doing that, we're partners with you to drive costs down in your system. We want to make it to where you can't do business without us, because we can drive costs down, create a more sustainable process for manufacturing your parts, or if you're a food pan, for cooking. whatever you're doing, whatever you're using water for. We want to improve your process to the point where we become integral to that manufacturing process. We help drive quality and we help drive savings. But in doing that, saving water is just the first step. Since water in these water systems, cooling towers, boilers, closed loops, it's being used for heat transfer. So when you save water, you also save energy. The best way to think about this is a boiler, and a boiler is an easy concept to think about. It's a pressurized vessel. You add water to it. Inside that vessel, you add fuel to heat up the water, and the water forms steam and goes off, and you can use the steam for whatever you want to. But let's say under pressure, we can get that steam to 300 degrees. So if you take water out of your faucet and put it into the system, and maybe it go through softeners first, let's say that water comes in at what, 60 degrees, 70 degrees Fahrenheit, then you have to heat it to 300. So you have to put enough fuel in to add 230 degrees of energy. And if you just let that steam, once it's used, it will condense into condensate. And if you just let that condensate go down the drain, you're always feeding in water at 70 degrees that needs to be heated 230 degrees to get to where steam is produced. But let's say that condensate, which is going to come back hot, you're able to recapture and reuse in your system. And that water comes back hot. Let's say it's 150 degrees. Now you only go to 150 to 300 instead of going to 70 to 300. So right there, you're saving that energy. So that's a real easy way to see when you save water, you're saving energy in your system. I already kind of covered this, but when used in manufacturing, if you want high quality results, you need high quality water. I think a good way to think of this is if you got a molding process and you're putting something, whether it's plastic or metal, and it's kind of liquefied so it can go into a mold, and then you got to cool it quickly so it sets. If you got water that has scale on it, or it has a tendency to scale, it's not high quality, it's got too high a calcium level, too high a carbonate, that scale, either number one, is going to form on the outside of that mold and affect the heat exchange to where you're not going to get your cooling done in the amount of time that it's designed, which could cause defects. Or number two, water always still, even though it should be sealed or whatnot, comes in contact with that part. And like I talked about before, you can get dry down assaults on the part. You can end up with water in different areas of the part that could be corrosive. So high quality production oftentimes requires a specific quality of water, and we need to deliver that. And those are hidden costs. If you have to have returns or recalls, or you just get a bad name out in the industry because of a lack of quality, that's all costs that, come back to haunt you. And finally, if we properly treat water, we prevent it from scaling and corroding. Water is a universal solvent. It's going to eventually corrode whatever it touches. When we do water treatment, our chemistry is designed to prevent corrosion and make water less corrosive or non-corrosive, but it's also going to prevent it from scaling. So all those things, calcium, magnesium, carbonate, phosphates, everything that's dissolved in water, especially at temperature, is going to have a tendency to scale up. So when you get to heat exchange surfaces, you can end up with scale on them if water isn't properly treated. That's a problem for two reasons. Number one, the scale on the system adds weight to the system, which eventually can cause the system to fail in the need for repair. And actually, it would be three reasons. Number two, the scale could plug up a system to where you got to clean it out in order to get water flow. And number three, scale is an inhibitor in terms of heat transfer. So you have a heat transfer system, a heat exchanger, which generally has some kind of sheet of metal between two fluids and allows heat to transfer between them without those fluids touching. But if you have scale on both or one of the sides, that heat transfer coefficient is going to go down, and heat transfer isn't going to be effective, which means you have to use more energy to get the same level of cooling within your system, or the same level of heating if you're using the heat exchanger to heat something. So when we save water, again, we save energy. So how does DuBois approach it, and how do we deliver those savings? Is number one, when we train our reps and when we talk to our customers, we don't want to be your supplier of water treatment chemistry. What we want to be is a partner and develop a proper water treatment program. We tell our reps that they should know the water systems of their customers and their partners better than they do, or as well as they do. If you don't do that, then we're just a chemical salesman like any other guy going down the street. So when we develop these total approaches to water management, we need systems that are going to promote Number one, water and energy conservation. Number one on the list. Number two, systems that are free of harmful scale and corrosion. Scale, again, is going to hurt the life of the equipment, and it's going to cause you to use more energy because it's insulating. And corrosion, number one, if it's manufacturing, you end up with corrosion on the parts, you're going to have an issue with quality. And number two, if you have corrosion in your systems, eventually they're going to fail, which reduces your equipment life, could cause to spend money on repairs or spend money to prematurely have to replace equipment. So we want systems scale free of corrosion. And number three, minimize the risks associated with bacteria growth. We want to keep our employees safe. We want to keep our customer employees safe, and our customers safe if they come in contact with aerosol or mist from our cooling towers and other water systems. So we want to treat our systems so they're free of harmful bacteria such as Legionella, and to prevent exposure to that kind of bacteria that can cause sickness. So how, and then finally, we already talked about manufacturing excellence and we get high quality. How do we accomplish this? Is our philosophy is to surround customers with all possible solutions. We're just not going to be a chemical salesperson. We're going to supply pretreatment and feed equipment. So the highest quality feed equipment, oftentimes that has ways to measure what we're feeding and what we're controlling in terms of conductivity, pH, all system parameters, have those functions so they can communicate online, so we can see our data and how the system's running from wherever we are. Pre-treatment equipment such as softeners and dealkalizers and filtration that can help change that quality of water up front. We've known for years in water treatment that if you change that quality of water up front, you can provide water savings. But number one, it's a cost. So a lot of people might not want to do it. But number two, it often involves bringing in more vendors. DuBois, we want to take control of that. We don't want to create a situation where you have a softener supplier saying, the system's failing because of the water treatment guy, and the water treatment guy saying it's failing because of the softener system. We feel it's important enough to our system that we want to provide the entire program, and we will sell and service the softeners and take care of that for you. Because if we say we're going to, solve water scarcity issues, we don't want to trust that to someone else to give us that quality of water. We're going to do it ourselves. So basically, we become a one-stop shop surrounding you with all possible solutions. Number two, innovative chemistries. All those companies that we've bought and brought in all have talent, which we've kept with DuBois. We have labs here doing R&D in Sharonville, Ohio, Calgary, Alberta, Grand Rapids, Michigan. Doing R&D work to make sure our products are always state of the art. And we'll develop something new if we need to. Industry leading service and support. A big part of my job is we provide monthly training, and the last few months has been bi-monthly training to all our reps in water treatment. We want our guys out there to be experts and no one to be able to beat them because they don't have the knowledge. We consider ourselves industry leaders in sales and service. And like I talked about before at the beginning, we can sell and service and have someone close by to you throughout all of North America to be able to come and survey your system, help design a program that's going to take care of the water at your facility and give you clean cooling towers and clean boilers free of scale and corrosion. And finally, best in class proprietary data management. Water treatment's become very data driven industry. A couple reasons for this. Number one, 10 years ago, 15 years ago, you only got service when your sales rep was on site. So what happened if he left on a Tuesday and wasn't coming back for 2 weeks and a pump lost its prime? You might not feed chemistry for 2 weeks and no one would know. Now with online data management, we can get alarms that tell us right away. This helps and can help save water in several ways. Let's say we have a product and we can run water at 500 M alkalinity and 1,000 hardness, and that you use up so much water doing that. But in the past, we might run that at less than its capability. Let's say 350 alkalinity and 700 hardness, because you had to build in that forgiveness in case something went wrong with the system when you didn't have eyes on it. Now we can run products to the ragged edge to really maximize water savings, because if something goes wrong, we know instantly. If a bleed valve gets stuck open, you'll know, within minutes. If a chemical pump loses prime, a flow meter can tell us that no products flowing through it. If water savings aren't what we're expecting, we'll see that in water meter readings. So we can always evaluate our systems and see how you're doing and really provide service wherever we are 24/7. What separates DuBois, though, is part of that Tri-Water acquisition. We have our own program for doing this. Most other companies use an off-the-shelf product, which is a good product. DuBois used to use it. But one of the things we can do with our proprietary program is we can really drive quality control with it. Instead of just taking in data, getting alarms if something's out of control, we can always use that data now to improve our systems in a data management approach. We have within our system a quality control loop. So if we're getting out of compliance readings on anything we're testing for, we get alerts. But if we get those, often in the same systems, those alerts automatically get escalated to our field technical specialist or to someone in a role like myself or one of our R&D chemists in the home office. So we surround with more people to get eyes on it and try to figure out a solution. It also helps with some of that pre-treatment and feed equipment I talked about up front, where that might have a cost up front, and you might not want to spend it, and that's understandable. But we can use data to show, hey, here's where your system is falling out of compliance, and we're not able to maximize your water savings because the alkalinity is getting too high or the calcium's getting too high. But if we did that, and here's the data to prove it, we could take your water usage from A to B and give you these savings. So you might have a $10,000 upfront expense and a $1,000 maintenance per year, but you're going to save $3,000. So in 4 years, you're going to pay it off. We use our data management to do that, not just to give us a pie chart that shows, 90% of the time we're in control, we're doing a good job. It's, we're doing a good job, but hey, we said we're going to deliver this much water savings. We haven't quite done it. Here's the reasons why, and it's in the data, and here's the reasons we can improve. We're always looking to continuously improve. The other thing it does is that 10% that we're off, how do we get that to the 5%? How do we get that to 1%? And those are that quality-driven function that we're able to program into the system is able to do that. So we're able to maximize savings because we have data coming to us all the time, which can alert us to problems, but we also use that data to drive continuous improvement as part of our quality control. So that covers our water treatment approach and how we're able to drive savings, both, again, good for the environment, sustainability in terms of water and energy savings, but also what we hope is to help with your bottom line as well in terms of quality and the actual savings you get from saving water and energy. But now I'm going to turn the page a little bit and go to wastewater treatment, and a lot of the same kind of thoughts and our same drivers apply to wastewater treatment too. So wastewater is often a hidden cost in the manufacturing process. If you're dumping the sewer, the municipality that owns that sewer, whether it's a county or a city or a town, they're going to have rules for using that sewer as far as what the quality of water that can go to it is, and you can get fines and surcharges if you're not meeting that quality. You also is part of to get that clear water or to deliver to the sewer, you take all the solids out, or you take a lot of the solids out in the form of sludge, and that sludge then needs to be waste hauled. So there's costs there as well. And then you have the cost of the actual wastewater itself in terms of chemical costs and equipment costs. So DuBois, like I said, is going to use a total program approach with wastewater treatment. I can tell you in my role, I sometimes get questions from people in terms of, hey, this is what is being used in this plant now. Do we offer this? And my first question back is, yeah, we probably do, but our first step needs to be to survey the system, look for improvements, get to know that system as well as any customer already knows it, because that's the way we drive savings. And if we just supply the same thing, either number one, why would they switch to us if we supply the same thing? Because to me, I'm only going to go to the work of switching my program if I think something's going to be better. And number two, we're not going to maximize savings for our customer by just applying the same things. So what we do is typically in our process, we'll survey the system, walk the host system, see where the water's coming, the waste is coming from. what the waste is and how it flows through the whole wastewater process. We'll then design a program that can meet all regulatory requirements in terms of volume, pH, the concentrations of contaminant. We have labs both in Cincinnati, Ohio, and in Grand Rapids, Michigan, that can take samples of wastewater and run tests on it in the lab to figure out the best program, the best chemical program to treat the water. And then we'll take that information and use it in the field and actually do jar testing in the field to confirm it on site before we implement our program. And like I said, we'll use data and online equipment to ensure our program is working as intended. And if there's any system upsets, we'll have the data to go back and be able to analyze and figure out what went wrong. And finally, we do have some innovative chemistries in wastewater. Those chemistries allow us to minimize chemical usage, which can further reduce costs. And we actually have an example here I'll walk through you with in a case study where we're able to do that and reduce cost to a wastewater system through innovation. So this case study, it's an account that was in the northeastern United States, and they take spent titanium from other companies that resulted from their machining processes and process it for recycling. So their wastewater would have different metals in it that needed to be removed and also had silica in it. It would then be released to the sewer once it met those requirements. When we came into the account, they were using an inorganic coagulant. If I remember, it was ferric chloride, but I'm not 100% sure on that. At a rate of 20 gallons per hour. Chemical expenses are about $150,000 annually, but the system also generated sludge that would cost about $125,000 a year. So to clean up the water from their process, the total expenses just wasn't the chemical expense. You got to add that sludge expense, was probably a total of about $275,000. So DuBois came in, surveyed the system, and when we did so, we had some challenges. Number one, the sales rep in the area was new to DuBois. They were from one of our acquired companies that did not have wastewater. So he wanted to sell wastewater to the account, but he didn't have a lot of experience. Another challenge was we didn't have much room to just provide cost savings on the chemistry because they were using a low cost inorganic chemistry that was about 38 cents a pound. And in general, the customer is happy with their system because they were meeting their requirements. Their water was clean enough to send to the sewer. And, you know, they accepted that the cost of that would be, you know, the sludge removal costs, what they were. So what DuBois did when we came into the system is first, like I said, we have water treatment experts close to you, wherever you are in the United States. So if you move ahead here, Max. So even though that rep at that particular account at the time did not have a great knowledge of wastewater, we're able to bring in 2 of our field technical specialists, a key account director, a sales manager, and a service and account manager, all came in to survey the system in at different times of the sales process. So again, we're surrounding our solution, surrounding the customer with our best people to, like, at the end of the day, it's a people-driven business. And we're going to bring all them together, put their heads together, come out with the best solution. We pulled samples, sent them to our lab run testing, determined what the best system would be. Then those people I discussed before out in the field came back to the account and they tested that program with jar testing on site over several weeks' time. It just wasn't a one-time shot based on lab study because the water can change. You take a sample one day, maybe it's different a month from now. So you want to confirm the system over several weeks. So we had experts on site pulling water at different times during the day over the course of several days and several weeks to make sure that our system was going to run as intended. So at the end of the day, what we came up with was a plan that brought significant savings to the customer. Number one, I told you that this case study was about innovation. What we did is actually remove the inorganic coagulant, the cheap product, with a product that was more expensive, but was a blend of organic and inorganic chemistry. So a lot of wastewater is commodity chemistry, but where we can innovate is with different blends that the innovations in both the stability of the blends and the concentration of organic to inorganic that you can do some unique things with. So this blend was higher. It was 54 cents a pound as opposed to 38 38 cents a pound. What's that, about 40% or so increase in cost? But usage was only 7 gallons an hour is all we needed to treat the water, as opposed to 20 gallons of product an hour. So yes, the per drum per pound price was 35 or 40% higher, but we saw a significant reduction in feed rate. So what ended up happening is our chemical cost went from 150,000 down to 75,000. So higher per drum per pound price, but a lot less in terms of use costs. Additionally, that product is designed to work well, but it works well in removing the metals that needed to be removed, but does so in a way that it generates a lot less sludge. So we generated about 50 to 60% less sludge than previous. That resulted in an additional 60 to 70,000 in savings due to not having as much sludge to haul out in waste haul. So overall, you can see there $75,000 in savings on chemical, another $60,000 in savings on waste haul cost. And the amount that company was spending with us then was 75,000. So we delivered more savings than what this account paid to us. And that's only done when you survey the whole system, have innovative chemistries that can be used, and find ways to use those chemistries to deliver the results. And like I said, even though that sales rep wasn't 100% up on wastewater, we had people in the area that could help them out, that would come in and survey the system, help them get started. We're there at the beginning and would make routine visits until he got up to speed on everything wastewater. So that's one of the advantages of DuBois is we have the production facilities throughout the country. We have R&D facilities throughout the country, and we have experts in all regions of the country that can help with designing and picking proper products to use in your systems. Okay, so another thing I wanted to talk about here is where I think DuBois is uniquely positioned, specifically with wastewater. And a lot of you knew DuBois because, through either a cleaning or metal pretreatment or metal finishing or metalworking type application, and that's fine. But a lot of our competitors in wastewater don't have that. They just supply the wastewater, and a lot of the competitors on the metal finishing and paint pretreatment side don't supply wastewater. They only supply on that side. DuBois can do it all. Where that is an advantage is, number one, in applications where we are doing the finishing and we are doing the pretreatment, we're really good at treating that wastewater. We know, even if we're not the chemical supplier up front, we know how to treat wastewater to remove metals better than any company out there. Metal removing, that sort of thing, we're excellent at. We're excellent in all kinds of wastewater, but that one we really have a knowledge base because of other parts of our business, and you just get those accounts more often. But number two, a lot of times when you have different companies doing wastewater and doing the upfront production chemistries, let's say the people up front decide to make a change, and it could be a great change. It could be a change that results in better cleaning, a change that results in less phosphate. But they can also have introduced maybe other metals to the system. Maybe you needed to get a higher salt spray, and to do that, you have mixed metals, and the way to do that was to etch the metal more. Well, yeah, you get your better salt spray, you get your better quality up front, but now you got more metals in your tanks, and when you dump the tanks, more metals that need to be treated in the wastewater. So when you make changes like that, we know how to adjust our chemistry to do that. So that's an advantage. But even bigger, if we're the supplier on both ends, we can make changes and use that synergy between the two to drive cost on both ends. So we know if we make a change up front, what the effect's going to be on the wastewater. And before we even make the change, what happens a lot is you make the change up front, and then you only find out that there's an issue with the wastewater when you get audited and your metals are too high and you have to pay a fine. We'll know up front that we're changing it. We got to look at the system, and we can run those tests in the lab. We can run them on site with jar testing, and we can change the wastewater system at the exact time as you change your system up front. And I think that's a powerful tool to minimizing costs over the whole operation, because you can't have production without wastewater. You have to treat the wastewater at the end of the day. So if you think of them as one big process, DuBois is uniquely positioned to drive cost savings and quality improvements throughout the entire operation. And I got an example of that as well. This was a customer down in the Southeast United States, is in the Atlanta area, and they're a manufacturer of construction equipment. DuBois was the wastewater supplier and water treatment supplier at this facility, but we did not provide the pretreatment chemistry. Because this facility was actually within the city limits of Atlanta, they always had a phosphate restriction, and we treated their water on the wastewater end for phosphate to remove phosphate. Everything was good until the city came and put further restrictions and further limited the amount of phosphate that could go down the drain into the sewer. So we had to come up with a solution. And instead of just looking at it the wastewater side and adding more cost and taking more time to treat their wastewater and adding more equipment and adding more chemistry, we came up with another approach because we could look at both sides. So what we did, if you move forward here, is we looked at the total system. So not just the wastewater, it's what can we do over the whole system? And the obvious answer was to use our expertise on the pretreatment side. So we came in with a system that would reduce phosphate levels by having a no phosphate cleaner and switching from an iron phosphate solution for the pretreatment to zirconium. So we were able to completely remove the phosphate from the process. So now we didn't have to add expense to the wastewater side to treat for phosphate. We introduced the customer to a whole new process, which could meet the salt spray requirements that they had, meet the cleaning requirements that they had, and at the same time, not have that phosphate present. The results were, number one, we met the quality of what they needed from their parts, and we were able to do it without phosphate. So the final thing we did was we were able to go back to the wastewater program, and instead of not increasing the cost to treat more phosphate, we were able to drive out costs of the wastewater program because we didn't have to treat as much coming back in terms of phosphate removal. We just had a different metal we had to remove, which ended up in a cheaper process. So again, by taking control of the whole production process from the front end to the back end, we were able to drive cost savings throughout the entire plant, as opposed to just saying, hey, we can get rid of the phosphate by changing our waste treatment system, which would have increased costs for the customer. Instead, they got actually better quality upfront and ended up with less cost in the wastewater. Additionally there, and I already kind of covered some of this, but we actually also in the cooling tower went to some of our innovative chemistries in cooling, and we have a product in cooling that isn't no phosphate. Phosphates are often used in cooling towers both as a corrosion inhibitor and a scale inhibitor, but we have a lower phosphate product in which we use polymeric chemicals instead of phosphate to provide that same corrosion inhibition and scale inhibition. We're able to switch that and reduce the amount of phosphate coming out of the tower by about 85%. I think we went from 5 ppm, a little below 5 ppm to under 1 ppm phosphate in the cooling tower water. So you end up with a system that meets salt spray requirements, has less sludge generated because that pretreatment process with zirconium generated less sludge than phosphate. So you have less sludge cost when dumping the tanks. And then the wastewater program was optimized to improve costs there because we no longer had to treat for phosphate. And then finally, we're able to also drive savings in the cooling tower by lowering phosphate in the cooling tower as well. Okay, so ultimately in wastewater, I think the ultimate goal in, overall, I think this would be the ultimate goal everywhere would be to have zero discharge, or if not, extremely reduced discharge. So if you're going to be a truly sustainable wastewater plant, you're going to reuse as much water as you can. And we're able to help with that, and we're able to do that. If you properly treat water, you can reuse the water in non-potable applications, maybe in cleaning stages or in other stages of washers and toilets, etc. Also, sometimes if you properly treat chemistries or properly treat the wastewater and use certain chemistries up front, that wastewater can be used for animal feed or irrigation, but only specific chemistries can be used in those cases. When you clarify water and get metals out and other impurities out, you end up with a sludge. And if you're not familiar with wastewater and you haven't seen sludge from wastewater, everyone thinks of sludge of looking like mud, but really in a lot of cases that would be a pretty good job if it looked like mud. In a lot of cases, it's more just like a dark liquid. Type thing. There's a lot of water in it, and so when that sludge is hazardous and you got to pay high waste haul costs to get rid of that sludge and have a company come in and haul it off, the more water that's in it, that's just more weight added. So we can do sludge dewatering as a part of the wastewater process to get as much water out of that sludge as possible, which lowers the weight of that sludge, and lowering the weight of that sludge makes it a lot less expensive to get rid of. Finally, demulsification or oil cook processes. So if you're using oil in your facility, you end up with oil in the wastewater. It makes sense for the water going to sewer to split that oil out. Well, that oil that's left oftentimes has, we're all used to oil and water mixtures and they don't mix, but sometimes there'll be water encapsulated in that oil. And that's called the oil and water or water and oil emulsion instead of the other way. And to be able to reuse that oil, you got to get that water out. So we have products and our experts in processes that can remove that water from the oil and have oil that then can be reused in the plant. So that's a way, to drive more savings. And then finally, there are reclamation systems that will use a combination of chemical and equipment to basically take a wastewater, clean it up as much as you can with chemistry, then run it through some kind of equipment similar to an RO unit to get water that can be used back in other facilities in the plant. And then you only have a small discharge stream. So there are ways to even further reduce costs in wastewater through reusing wastewater. And we're happy to partner with you and help to develop and design those systems where possible. It's not possible everywhere, but where it is possible to be able to do that. So this is just in summary, through best practices, DuBois can use a total system approach to water treatment to drive costs out of the production environment. Water and energy use integrity, both to help our environment, help you meet your environmental goals, but also to help drive costs down. We can increase equipment life, have less downtime for repairs by preventing scale and corrosion, and also promote manufacturing excellence by having high quality water available when you need it for your processes. But we can also do the same thing in wastewater. Hidden costs in wastewater include fines due to compliance issues, so we can design systems to avoid that. We can minimize sludge haul out costs, reuse and recycle water and oil. And then, like we talked about, having that synergistic approach with the upfront production chemistry and the back wastewater chemistry can really drive cost savings throughout the entire system.
Awesome.
So you got it here, Max?
Yeah, no, thank you so much, Rich. No, I thought that was a great presentation. Again, talking about how DuBois can help you in water management as well as your wastewater treatment. Now, just, we got time for a couple questions we see here. What do we got? First, in terms of wastewater, is there any technology that's kind of growing in this field? Anything that's dying out from regulation? Just kind of, what are you seeing on that front?
Yeah, there are some new things out there in wastewater, and we're actually developing, or probably past development and more into testing now, trying to use more, I don't know if organic's the right word, but more natural substances that can do the same thing as some of the inorganic salts. Using stuff derived from the ocean and derived from animal sources that are renewable. So there's definitely a trend to using more renewable resources. And the other thing really with wastewater in terms of regulation is we start seeing more stringent requirements in terms of how much, what pH range you need to be at, how many, what are the higher or upper limits of the contaminants such as metals and stuff that are allowed in the water, which can create challenges for the systems. In a lot of cases, some of the older, cheaper chemistries can't really get the job 100% done, and you have to look to the more expensive organic type chemistries. So that's really what we're seeing. We don't see as much with certain limits to the treatment in terms of, hey, you can't use ferric chloride anymore, you can't use calcium chloride anymore, and some of these salts. But what is more challenging is you know using those chemistries to get to the new requirements in terms of how clean the water has to be.
Awesome. And the last question we have, the only other one we really have today, is what's kind of the most common mistakes you see when it comes to wastewater treatment, or things in that vein?
Well, wastewater treatment and water treatment both. So a couple things in wastewater, I think some common things we see. Number one, stuff like pumps losing prime, that sort of thing. So that's where automation can come in to help prevent some of that. Also, sometimes in wastewater, if products, especially with the flocculant polymers, if they're not fed correctly, uh, they won't work. So oftentimes you have to make them down in a makeup tank and then mix that tank. And if you over mix a tank, you can shred the polymer. And if you under mix a tank, the polymer doesn't ends up kind of bunched up, I guess, on a microscopic scale and doesn't work as well. So it isn't as simple as just dumping chemical in a tank and it does its job. It does have to be fed in certain ways. Um, the other issue we see in wastewater occasionally is, and I kind of touched on this, is let's say you have a pretreatment operation and you generate a certain flow of water and you're going along well, and then one day you dump all the tanks. So all of a sudden you're going to get a lot more metal. You're going to get a lot more oil from the cleaning stage. You're going to get more of the chemicals and process chemistry, all that all at once. So your system needs to be designed to accommodate that, whether it's through storage tanks and you let the water sit for a while to get a common state before you send it through, or having other mechanical controls to adjust your feed of wastewater treatment chemicals when you do see changes to what is being fed. But that's one of the most common mistakes, is assuming that your flow on a given day and your contaminations in the water on a given day are always going to stay constant. On the water treatment side, um, probably the most common things are similar. Probably the simplest is, someone walks by and catches something on a pump and unplugs it, or for another reason, the pump loses its prime, or the chemical drum ran out and no one changed it over to the new drum. So we end up not feeding chemistry. But again, having online controls can alert us to that, because you can see no flow rate of the chemical through the system, so something's wrong with the pump. You can have level controls on the products, so that there's no product left and it needs to be changed over. So that sort of thing is less of an issue nowadays if you're using the right technology. Similar in water treatment, bleed valves getting stuck either open or closed. So if a bleed valve gets stuck closed, you end up with all the solids in the water cycling up too high, which can cause scale. But if it gets stuck open, either number one, you're probably going to underfeed chemistry. And number two, the water is going to be a lot corrosive because it isn't going to have any salt in it. Both of those are common occurrences. I wouldn't say common, but most common in terms of the errors. But again, with proper water meters, you can tell what the bleed should be. And if all of a sudden it goes to nothing, or it goes triples or quadruples, you have an issue, and it's something that's an easy fix once you have an issue. So that's a lot of the mistakes we see is stuff like that, but it's all stuff that nowadays can be detected more quickly than it could have been 10, 15 years ago.
Awesome. Well, I do not see any more questions, so we'll call this to an end. So, Rich, again, thank you so much for giving this presentation. It was really great.
Thanks,
Just as
Max.
uh, just as a reminder to everyone else here that we're going to have this presentation and all three presentations previously up on our YouTube page. So go check those out if you weren't able to listen to them. And we are going to be exhibiting at FabTech. Again, please feel free to seek us out in the finishing pavilion. And we're going to be giving two different talks, one Tuesday at 10 a.m. and one on Thursday at 8 a.m. 8 a.m. one's a little bit rougher, I understand. But yeah, so thanks again, everyone, for jumping on. Have a great afternoon. Thank you.